What are the odds? So easy. Haha. XD lol. Haha. I don't know what the FSR is. We'll fill in these flags and stuff once we get this working. Okay, so now what we want to do is we want to actually invoke this. And what we want to do is start off with this, and then we'll say that this is a context, and this is going to be a core mem zeroed. Just because we're lazy, and we'll fix this later, but we don't want to implement stuff on things that we know are not going to work, and then we're going to have to fix them anyways. It's okay, the mouse is fucked or something. I don't know. The mouse is fucked, so that so I didn't cause your liver. Oh god, oh no, oh shit. What do we need? We need like context all? Context full. Honestly, just like 1, 2, 4 probably looks good enough to me. I don't know. Context full. So we'll do context.context32. I mean, we have no idea if it's 32 or 64, to be honest. Actually, context.context.bits32. This is unsafe. Is equal to 5. Bits 32 dot flags is equal to context control, which is alpha, that, or 1 or 2 or 4. Okay, so that is that's technically the flags. So then we'll say context.context.bits32 dot alignment argument 32-bit context int. We have an RA FSR contains the flag. Okay. The registers GP, SP, and RA are defined in the integer section, but are considered part of the control context rather than part of the integer context. FIR and PSR. Do you think FIR is where I want to execute? And then PSR, I don't know. FIR, fault instruction continuation address. PSR, processor status. People want to lip vibrations. Okay, create thread 00. We don't care about access, because I don't need to access the new thread. I don't think so. Create thread, context and tab. Maybe I need to set up the tab. Let's just initialize this to 1, 2, 3, 4, 5, 6, 7, 8. All right, let's just put some A's in there, and then let's just fucking ship it, chat. Let's just fucking ship it. Context and pub and pub. Okay, CMD, CD shell code client, server dot, explorer dot, send to create shortcut to this, properties. Shortcut target run in that. Okay, fan-fucking-tastic. All right, and then we can go to startup. It's where is it? WinNT startup. Start system 32 startup. Where the fuck is startup? Oh, I bet I can do this. I bet I can do this because it's Windows. You think I can drag this into the start menu? No. 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 Where's startup? Do I need to create it? Does it not exist? System. Fuck. Fuck. Oh, there's a profiles. Who am I? Admin? Start menu? Programs? Startup. Ah, son of a bitch. Do you have any 4-1s anywhere? No, don't see any 4-1s. Oh, there's a PSR. There's a PSR 2000 FFA1. I wonder if it's like switching the PSR or some shit. Is this gonna work? Oh, fuck. Do I have to log in? I don't like that. How do I turn on auto login? Please, please launch. Please launch. Even with this pop-up, please launch. Gonna give it some time. Shit. I mean, it's still an improvement. It's just not great. Client ID 1234. Handle 1234. And this is just gonna be core mem. Shit, I shipped it. Okay, do we have any A's yet? No A's. Fuck, dude. It's gonna be a long night. Well, I mean, how are we supposed to know how this API works? It's so difficult. So difficult. I mean, we definitely don't need threading yet, but I mean, we've made progress by being at the thread. Okay, here's what we're gonna do. We're gonna do context is equal to. How do I initialize this to that? Unsafe. Let mute temp is equal to core slice from raw parts mute is equal to context as mute context. Mute context is mute context as mute U8, and then we'll do core mem size of val context, and then we'll do temp dot iter mute dot for each x is equal to 41. Oh, it is launched. It's totally launched. Okay. Cool. It's at least launched behind that dialogue. Let's see if we even need to log in. So we got to do that. We go burp. Okay, and then let's see. I'm guessing it won't be started yet. That would make no sense. Yeah, it's not started yet. But if I do that, then okay. So what? Okay, literally everything is filled with A's. Thread context create suspended Boolean. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Whoa. 1, 2, 3, 4, 5, 6, 7. Okay, so I think it just derefs the pointer that you give it for one of these. Probably this one. Probably the context pointer. What? Is it the tab one? So this is what we had. Yeah, I literally had the arguments in the wrong order. Whoa, what's going on there? Oh, does it need to be a kernel address? Nope. Okay. What if these are both 0? Okay. Something related to context. Or more specifically, this is actually, this is the third from the bottom. Okay. I saw device error, but then it went away, so I think we're fine. So is it this? Okay, that doesn't crash if we do that. So maybe it's because that's not like aligned. Is your lifetime BSOD count? Pretty high. Okay, anyways, we'll just go back to this. This is correct. Okay. I don't know why that's succeeding somehow. Okay, so fur. Let's just say OU64. And then this and these will just reset back to zeros, and handle will just be 0. And let's see if we get a handle. Because if we get a handle, we probably succeeded. Yeah, we got a fucking handle. Okay, so that did something. Now, did that thread just crash immediately? Who fucking knows? But that, okay, that's a good sign. So let's see if, extern fn moose, print moose. So now what we're gonna do is we're gonna try to get moose to get hit. Okay, so we didn't get moosed. So I don't think it's fur. I mean, we can set kind of all these things. PSR and FSR. But these are like status things. It's probably not even using these. What about int GPSP RA? Maybe RA? Which would be int. I think I called it int. Yeah, int 32 or 31. U64. Okay. Unless it's the tab. Let's just make some, let's put some mooses in here. Okay, so that's not doing it. Well, we've put moose pretty much everywhere. Fuck. Is it because it doesn't have like a stack? Do I need to allocate a stack for it or some shit? Because it's succeeding. Context, P initial tab. Initial tab. Initial tab. Stack base. There's a bunch of shit in there. Putting in the flags. All right, here we go. Ready? Chat? Chat? Open your eyes. Open your eyes, chat. Open your eyes. Okay. We good? All right, let's go. Da 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 da. Da 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 da. Gonna make a thread and we're gonna create thread and we're gonna create the red and we're gonna make a stack size and we can say 0 because it doesn't matter. Then we'll say we want to execute this and then we'll say this is the parameter and then we'll creation flags is 0 and the thread ID is null and then da 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 da. Oh, those are just warnings. Those are fine. They're casting things. You can just cast whatever you want. It's C. Who cares? Damn it! Hello world.exe. Okay, that looks pretty good. That looks pretty good. That looks pretty good. Okay. Int astiff. Printf astiff. Let's just make sure astiff works. Because if astiff works, then we know we're working just fine. Okay, that's okay. Okay, so we're just not void star param. Is it void star, I think it is? Yeah. Unsigned long. I think that's the word then. Security Live, thank you so much for the 4 months of support. There we go. Okay, so that's not working. We might have to fill in a couple things here. Stack size in bytes. If it's 0, it uses default. Security attribute shouldn't matter. Astiff is that. Parameter is the parameter to pass to the thread. LP thread, I don't understand. Oh, it's because I need to do this. It's just not getting time to execute. Okay, let's go to a more reasonable state. I think fur would make sense. Let's say OU64. That's fine. Okay, we haven't gotten moosed yet, unfortunately. So we're probably not doing it right yet. I think we probably need to make a stack or something. I don't know. Like, sometimes people say stacks are important. I'm not super convinced about stacks being important. CDB. NTSD. Okay, cool. yeah. Okay, IR. Okay, so this is the register state. So, registers. This is the handle. Handle, that should be an address. Yep, that looks like an address to a thing. 2. The second parameter is, I don't know, it's some dumb shit. Probably don't care about it. Access mask? Yeah, that's the mask, okay. 1FO3FF? 1FO3FF? Okay, that's not it. 1FO. Yeah, 1F03FF. So that's the access mask. First one's a pointer to a handle. That's probably zeroed out. So DWA0. A0. How the fuck do I... is that A0? No. 12FC14. Fuck it. Okay, that's just probably some uninitialized shit, so that's fine. A2 is 0. Yep. This is -1. Yep, that matches. Okay, and then the next arguments are going to start being on the stackaronian cheese. So let's take a look at the stackaronian cheese. DW, SP plus 10. So we want to take a look-see at SP12FBC8 plus 10. And I want DD, I guess, here. Okay, regs 12FC18. Okay, that's an address of some shit. An address of some shit, an address of some shit, and then a 1. What's the 1 for? What's the 1 do? Create suspended. Oh, I don't want to create it suspended. No. No, that ain't for me. That's not my cup of tea. Okay, so that means that we have a context first. A client ID. So the client ID is probably some just uninitialized shit on the heap. DD12FC18. Yeah, that doesn't look like anything relevant. DD12FC40. So this should be a context structure. Woo! And that's a lot of zeros. That's a lot of zeros. That's a lot of zeros. U asked if. DB asked if. DD asked if. Okay, sick. Okay, that's just fucking useless. DDL, how many words was this thing? Was it like 268 or something like that? 268 divided by 4? Or 268 divided by 4 or something like that? Something like that, 67. Hey! 1017. 401, that's Astif right there. Okay. Yes, this looks good. 77EA. It's 568. It was 568 bytes. So it's 142. Is it? Are you sure? 568 sounds big. Size of syscall context. I swear to God, if this is 568, I'm gonna be pissed. Ah, it's fucking 560. Fucking dumb. 568 divided by 4. That's 142. That's a lot. Okay. All right. So let's go find what we have here. I like the ones that I had at the start because those look good. Because that looks like these look like real things. Okay, so we know that there's 10 hex at the start, right? We know that there's 10 hex that we want to skip. The 10 hex that we want to skip is the alignment shit. So that's gone. So we skip past this 10 hex bytes. Then we're in context 32, maybe. So let's get past 4 times 32. 32 is 20. Okay. And then let's go L20. Okay, L30. Ooh, okay. So that's You know what? These look like 64-bit. Maybe not. Wouldn't make sense for a 64-bit thing to be up there. So let's take a look at, let's go 34. That plus 10 plus ON 34 times 4 plus ON plus ON 32 times 4. Okay. Okay, so we are now here. So we have an FSR that is 0. We have a fur that is that 77EA 8810. Okay, I can do that. 77EA 8810. Sounds like a fantastic fur for me. Okay, so we got a fur. Then we have a 0. PSR. And then flags is 1017. 10017. Okay. Maybe this is the address that it's executing. I just don't think it's be up that high. I feel like I want that for yeah, I mean, those look like real things. Those look like real things. I just don't think that's code. 77EA 8810. Add IU or I. Oh, that's base thread start. Oh, okay. Yeah. Well, that's, yep, that's, oh, yeah. Holy shit, we had it right. We guessed that one, right? Holy shit, we're brilliant. Wow. Kind of no surprise there. Okay, then moose, loop. Actually, what if I do, can I do an exit process? Because I don't think exit requires a stack. It might. Shit. If that doesn't require a stack, is that true? Spawn, moose. Let's go find moose. Oh my god. Unsafe. Let's just do an ASM break. And then options, no return. Moose, break. Where's moose? Debug. It's true. Rip. Debug equals true. When's react us from MIPS? I don't know. Might be time to change your camera resolution? What do you mean? What do you mean? What's wrong with my camera resolution? Oh, the focus? Was the focus fucked? Is the microphone floating towards me? Oh, is it? Oh, I see. It's out of sync. Holy shit, that's bad. Fucking, what the shit? Okay, test. What the fuck? How is that drifting? Sick. Okay, so this is now a thing, and then I have moose. Is that moose? Where's Moose? Oh, it's getting DC'd. Moose, break. Okay, nice. Okay. All right, let's go. Let's go. Let's do this. Let's do this, chat. Crash. Fuck. I don't need to give it a stack, do I? DD SP plus 10. Wait. Is that actually the stack? Yeah, that is. What the fuck? Can I poi? SP plus 10? Oh, fuck yeah, I can poi. Okay, so this is the first thing. Doesn't look important. This is the context. Then this is the stack. Ooh, and that looks maybe stacky. That looks like it's maybe stacky. P initial tab. P initial tab. Stack base, stack limit, stack commit max. That doesn't make sense. Commit max reserved. I mean, I don't know, man. I don't know. Let's just slam some of these in the tab. Let's slam some of these in the tab and see if that crashes. Nope. Okay. We can poi SP10. That one doesn't matter. This one is good. SP14. Then if we say, for the size of that, it's 32 plus 34 plus like 4 or something like that. Times 4 is 280. 280 bytes plus, that's 118 hex. Something like 118 hex and then 16 more at the front. So like 128 hex. Unless break isn't hard enough. Maybe I need to like load immediate A0 OX 41414141 load word A0 from 0 A0. Right? Okay. Exodus. Come on, give me a pseudo instruction. What? Unexpected token. Unexpected token. Oh, these fucking things. Whoops. All right, there we go. And bam, and it's running. Okay, that's not good. Because if I ran this here, this should crash, right? If I put this in an unsafe, this will crash in a visible way, right? Yeah. Exception alignment fault. Okay, fantastic. So we would expect that something like that would occur if we ended up getting execution in that thread. So it seems we're not doing it right yet. Is it the stack? Do we have to give it an existing stack? In which case, what is the type of that stack? I'm trying to think what could be stacky here. So this, honestly, it doesn't, actually, that's too much. Yeah, this is a number of, not bytes, but words. So this is, how many words do we have? 32 plus 34. If we look at the structure, so I want to look at the entire context structure. Make sure there's nothing we're missing. So the entire context structure is, that's 4 D words. So we have 4 D words. Then we have 32 D words here. Plus 32. And then we have an additional, that should be 34 D words there. Then we have 1, 2, 3, 4 more D words. So we have 74. So ON 74. This is the entire structure for the context. And that makes sense. Yeah, the last thing in there is the flags, the 1017. We got the fur, which is this. So 2 before that is the fur. Yep. So that is the fur. That's where we want to execute. Everything else is 0. So we have 100% set that up exactly as they're doing. Okay. So then the next thing is the tab. This initial tab structure. So this initial tab is, we don't know how big. But honestly, this looks like a top of stack, and this looks like a bottom of stack. That looks like a 32K stack, or a 4K stack. Right? Does that not look like a 4K stack to you? Because that's what it looks like to me. Top of stack, bottom of stack sort of thing. Stack base limit commit. Commit max, stack reserved. Okay, so let's try it. Let's try it. We're gonna say this structure is like 16. I'm gonna say OU32. Then I'm gonna say teb 0 is equal to 0. Teb 1 is 0. I know those are redundant. 2 and 3, and then we're gonna give it some stacks. So 5, 1. So we got a high and then a low. So we're gonna give it a high. This is gonna be a vec. Let stack is vec OU8 4096 dot leak stack SU32 leak. I think leak gives you a pointer. It also might need to. Nope, that's good. Okay, so stack as mute U8 as that. Okay, this as pointer. And we'll say mute, not that it really should matter here. And then that's the high one. We got a high one there. And then it's the low one. So we'll take tab 2 minus 4096. Okay, so then we have a 410. And what's this? Is this a thing? U77EC 7A8C? Get startup info? What is that? Is that real? I don't know if that's a real thing, chat. How much should I expect to earn as an experienced reverse engineer? Anywhere from $0 to probably 2 mil a year. I think you should swap your Teb 2 and 3. Oh, this should actually be this plus 4096. And this should be stack.asMute pointer as U32. Because this should be the higher address and it should be pointing to the end of the stack. Unfortunately, that didn't do it for us. What's 410? U410 123. Minus 1. Minus 4. Okay, so that's a real thing. So that's like, I think that's the end of the program or some shit. This is like you can grow until this point. And we'll just say 410. Fuck it. Okay, and then what's this other thing then? 77EC, 7A8C? Okay. Teb 5. 77EC, 778C? Was that it? EC8C? 77EC, 7A8C. But I don't think that's gonna do it. The fuck else could it be? Could it be that client ID? NT create thread. Tab I don't get it. I mean, we're clearly looking at the whole context here, right? There is nothing in here that's filled in. Everything is 0. Right? Everything is 0 there. And then this. The fuck? That does look like a top end and like maximal expansion region. Like basically your stack can expand down to this 410, but this is the current range of the stack. Why wouldn't this just fail? Good night. See you around, dude. Li that. Moose. Okay. Give it the address of moose. And a fur. U8064CCEE8. Yeah, that's just garbage. Okay, so that's nothing. What the fuck, dude? I didn't understand. Have a lot of fun. Yeah, get some good sleeps. What else are we possibly doing wrong? Client ID. Process handle. Yeah, that's the current process. Thread all access. We're getting a handle out. We're passing null as that. And maybe threads just don't crash in the same way or some shit. I don't fucking know. Print astif. Are you going off CPU? Like when you called sleep? I mean, my loop firmer. Shit. Stack, leak, top of stack, bottom of stack, super bottom of stack. Here I could probably just say like stack as mute pointer as U32, just like that's the true bottom of the stack. Fuck. Context tab. Context tab false. Client ID. I don't know. Shit. Let's try this. Let's put a 1. Okay. Okay, 1 didn't help. Because that's supposed to mean create suspended. I don't have to like resume that thread, do I? Do I have to start that thread? I mean, if I don't give it create suspended, I would imagine it would just run. I'm trying to find another reference. Let's see what GitHub has for NT create thread. Exploit DB. Some exploit DB. Okay. See if I can search for. Can I do def colon? Is this called def? NT create thread. NT create thread. ReactOS does resume after creation? Really? Do they pass it a 0 here as well? Where are you seeing that code? Can you link that quick? Thanks. Cheers. Create thread. This creates it suspended. And that's why I'm kind of interested about that. So object attribute H process, client ID, context, and initial tab, but it creates it suspended. And that's kind of interesting to me. Create base stack, base initialize context. Client ID. Unique process is H. What? Client ID. Write the PID. H process. So that would be poi 10. So we did see stuff in here, but I just thought this was uninitialized shit. U208-0036. U12FA10. DD. 12FA10. Okay. That's interesting. And then that's ASCII. 3,000. It's hard to say if that's just uninitialized shit. Really hard to say. Yeah, if creation flags is not create suspended. So it defaults to suspended. I would imagine that suspension flag actually matters. I would hope. Okay. Check if it was from user mode. If it is, then probe this shit. Yep. PSP create thread. Basically everything's passed through as is. So let's see. Start routine, blah, blah, blah. Start routine. Create object. Zero the E thread. Okay, let's see what sort of things we pass in. Let's see if initial tab. Let's take a look at that. Create user mode tab. Okay, so you give it an initial tab, and that's interesting. Let me just git clone this quick. Okay. Boop, 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 boop. Jesus, this is big. Holy shit. Create tab. System thread. So, yep, not a system thread. So, create tab, that's where that syncs. We have a thread context. And that syncs. Kernel initialize the context. Get the PC and the return register. So the Win32 start address is the return register. PC, okay. Okay, so that's like getting some of that shit. Okay. We might be in a different function as well. No, we're not. Okay, create suspended. That literally determines, I'm guessing, if it creates it suspended. Out client ID. Okay, so this is the first place where we see the client ID should be an out. And I think that lines up with a couple other things that we've seen. Yeah, we shouldn't have to initialize the client thread. So basically, the question is like, what the fuck is the initial tab then? Base limit, commit, and commit max. Base limit, commit max, and reserved. And that kind of lines up with what we're seeing, roughly, structure-wise. We are seeing basically 4 things. Base, limit, commit max, that. All fields of this should be null? I don't know. I mean, I can just try resume thread and just see what happens. Obviously, I don't think we're gonna have a context, because I don't think they have MIPS support. For Moose's U32, and that's the exact same setup that we observe. That's the exact same setup. So if you go back, once again, this, okay, 1017, 1017, flags, and fur of that. I mean, unless this thing's like unaligned or fucked in some way. Let's just say U128. Let's make sure this is, let's make sure that this is actually aligned to that boundary. Because I know that they care about that 16-byte boundary, but yeah, it doesn't seem to do shit. Okay. Unless I'm crashing that thread and it just is silently crashing. But I just, yeah, I mean, we could do an exit process. Because everything we give it is the same. Regs. 12FC14, that's a pointer. 1FO3FF, that's the same. 0, this is the same. Client ID, that, well, we don't really know what client ID is, to be honest. So client ID, we still haven't figured out what the structure is. Sleep calling something to reschedule you. It should be able to have multiple threads running like that. I mean, we can maybe resume thread. This is kind of interesting to me. DD208036. That's nothing. So I think that's just uninitialized shit. Let's see KB. This is create remote thread. Let's go take a look at create remote thread. Create thread. And this is kernel 32. Okay. Create remote thread. So let's see what it passes into create thread. Honestly, we can probably... Okay, let's just go to create remote thread plus C0. Okay, so we are here. Okay. And since we're there, let's go and see if we can get something better with HLIL. Yeah, sweet. Yeah, that makes sense. So, oh, yeah, literally that's constant. So we have that. We've got a V0. In our case, that is literally 0. Is it? We have an address, we have that, we have a 0, and then we have the current process. So this is get like current process probably. So that's all Fs. So all of those are the same. var 318 is just declared right here. So that's uninitialized. 2FO is initialized. B8 is initialized. So 31C is not initialized, and 318 are not initialized. So we do not have to worry about this fifth arg. So whatever this fifth arg is, client ID. Yeah, client ID does not have to be initialized. Okay, perfect. And this picks it up as a doesn't really know what the type is, but who cares? Then we have 2FO. That gets initialized in here, and that is our context. Yeah, this is our context. So this is going to be initialized context. And so it memsets it for, it zeroes it out for 238. It sets 208 to 1. So 238 should be the total size of that structure. So if we do poi sp14 lo, it was 248 hex. 238 hex. Divided by 4, since we're printing D words. Oh, there is some more stuff down here. And there's the 1, and there's the... okay, interesting. So what are these? These are... That's potentially a return address. And then this is potentially SP. 64-bit SP, 64-bit return address. But that would be weird. There's nothing else that deep in the structure. I mean, I'll fucking set those. But, wow, that's really weird. But it is definitely explicitly setting those. arg4, that's probably the stack. 220, it's setting to 1 as well. Is there another one in there? I'm not seeing anything else in here. I'm just seeing those two. So this would be in a 64-bit context. This is MIPS high, MIPS low. This is RA. This is S8. This is SP. So I guess we'll try it. Let's just try context.bit64.int, and then 31 is RA, and it set that to 1, and then it set 29, which is 2 before, which is SP, and it set this to something. Let's just set it to stack as mute pointer as U32. Fuck it. Maybe that's how you signify that you want it to run as a 64-bit process, is by putting an RA like that? Well, that didn't do shit. Oh, thank you so much, Pokemon fan, for the 2 months. Dude, you're so smart. Holy crap. I mean, I have no idea what I'm fucking doing right now. I'm kind of just winging it. Okay, so we have... that's basically the same now. Right? 208. Pokemon alt. 208 hex. 208. And if we divide 208 divided by 4, that's 208 divided by 4. That's 130 viewers into there. That's writing 208 210. Oh, is this 220 208 210. arg4 minus 40. Okay, that's really interesting because that's that C0. That's minus 40. Oh, fuck. Plus 4096 minus OX40. Maybe it needs 40 bytes at the start of the stack. Yeah, we're pretty fucking smart, chat. Woo! Easy. Fucking easy. All right, Teb, does that matter? Nope. Is this going to execute this as 64-bit? Like, what is that? So an array of 1, apparently? So that's the end of the stack. 100%. So this is the stack. You set up SP, and I guess you have to give it a 64-bit stack. Okay? Fair. So we give it the stack address plus 4K, the top, and then we subtract off 40. But if we don't subtract off 40, this fails. No, that works. That works. Okay. So maybe I don't need the minus 40. So I should come into here, and this pointer, yeah, okay. So yeah, we just start there with our stack. And if we add 4 to this, this should crash. This should just not execute. It hangs. Okay. So, that's good. That's good. Okay, so that definitely seems to be giving it that stack. All right, so now that makes sense. So, okay, close, close, and close. Okay, now everything's closed. And we have our flags. We have our function that we want to execute. We have our stack that we created. And then we have a Teb, which I think only needs to be 5 for the initial. Let's try 4. This should just fail. Okay, that succeeds. If I page heap allocate this, so if I take this is now allocated a page. I don't know, whatever. I think that's 5. I'm pretty sure this is 5 fields. This initial tab. Initial tab. Okay, initial tab. Maybe some stack stuff in here. Okay. And then what if I don't give it a stack here? If I just give it a 0, what happens? Will it just allocate a default stack for me? No. Okay, so I need to explicitly give it the stack. Probably have one hanging. Yep, I do. Let's minimize that. So we're at a clean desktop. Allocate and leak a stack for the thread. Create a new context. Placeholder for returned client ID. This is holder for returned client handle. Okay, then down here we do this. We create the thread. We don't need to print the handle. Okay, should still be working. Failing to build. That's okay. Let's just clean these things up a little bit. Expected blah. Okay. Yeah, that's fair. Let's do let status is equal to this. If status success, we have this code in a million places, so let's just do this. If it was a success, convert error to Rust error. Then we can do this. Okay, blah, 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 blah. This will return a result. Okay, and then we still are leaking that address. That's good. Okay, status. This is an NT status this as U32. Boom. Okay, so this is create the thread. We don't really know what these flags are. Honestly, we don't necessarily care, do we? What if 0 is fine? I think these are the permissions of the handle, so we don't really give a shit, to be honest. Okay, so NT create thread. Yeah, it's the thread execution block. It apparently has some shit in it. I don't know. This is like a partial tab, so I don't really know what it is. I know what like a normal tab is, but this one not so much. Okay, so let's. These are reversed out, unfortunately, but that's okay. Desired access. This is basically. Oh god. This is basically the desired access of the thread, and ultimately the desired access of the thread is I don't give a shit. or of the handle. So we don't care about that. Then we have the object attributes, which is optional. Obviously, we take the optional route because it's less work. Then we have the process handle that we want to create the thread in, which is our own, so -1. We have the pclient ID. We have the context, which is the initial context of the thread. Then we have the initial tab here. And then we have a Boolean of whether or not we want to create it suspended. And then, of course, we have the actual syscall itself. Okay, so what we do is set the 64-bit array to 1. Does this signify 32-bit? Set the 64-bit stack address to the end of the stack, and this can be stack.len as U64. I'm pretty sure we can just do that, right? Yep, because we know the size of the stack. This is the thread entry point, and this is the thread context execution. This is just the context flags. And we could probably just find context control, which is 1. Let's just see if context control is sufficient. And it is. What if we just have 0 flags? It don't seem to matter. Yeah, I don't think they matter because it's thread creation and they just like have some default shit. So fuck them. Okay. Holder for returned client handle. Placeholder for return client ID, create a new context. We got these. We're setting up the thread entry point, the 64-bit RA. RA to that. Okay. Then we're setting the 64-bit SP to the end of the stack. Thread entry points. Okay, nice. That looks good. Bit 0 is the moose bit. Yeah, that's definitely the moose bit. Okay, so now, holder for the client handle, for the client ID. This is the new context. We know that our context structure is the correct size. So this is 32-bit context, and this is 64-bit context. Okay, this is context update flags. Down here, context update flags. FSR status register. I don't know what the fuck that is. Okay, that looks good. Let's see if we can make Clippy. Probably not. Okay, good. We definitely can't. Print ln. Yep, that's fine. Print ln. We've got println, we've got a B-tree map unused, we got an unreachable expression, we got an initial tab that doesn't need to be mutable. That's because we probably are not saying it's mute. And, yeah, I guess maybe that doesn't have to be mute. And we have a stack, make Clippy, spawn, result unused. Oh, everything's documented. Oh, except for moose. Well, that's fine, because moose doesn't need to be documented. And then the thread. Okay, now we want to do some Rust stuff. We're just going to steal what they do for spawn, because they probably have it right. Okay, so we're going to have a spawn f of t, f function f, where f is an fn once, which yields a t. And f implements send and static, and t implements send and static. And if all those things are true, then we're happy. Okay, so now we should be able to do print ASDF, println. Still not in the habit of doing that yet. This is called spawn. Println moose. Moose. Okay, so how do you get the address of a closure. FN once. I probably can't directly execute that as well. Yeah, what is that internally? An FN once? It has args? You pass an args to it? It's the only trait that implements. So we have to key off of that trait. And that gives us a call once, which is a rust call, an extern rust call. And you pass in args. I don't know how you do that. How does this work internally? Type of the return type if the call operator is used. Yep, that's the output. It's an FN once. That yields a T. This yields that. So I probably can do this right now, but I wouldn't be able to do this if I have variables. So let's just try this. We have an F. We're going to say this function. We're going to get the call once as U32. Okay. Whoa. Required methods call once gives self the return type after the call operator is used. Self output args. Shit. Gotta find the method function. Yeah, I'm just kind of curious. So no parens on call once. Method not a field. Value of method call once on type F. Yeah, I might have like a thread dispatcher, like a thread entry. Let's just try this for now. Let's try entry as U32. Okay. So obviously this should work. And that will get stuck because we don't call exit. So in here, we're just going to call exit. This is just so we don't have things getting cluttered up, but that correctly, yep, that exits. So we're definitely getting execution here. So what we could do is hopefully maybe marshal that in as an argument. So that would be, let's see if context bits 32.int, I think 4 is the first argument. Let's just see if 69 comes up. Print arg. And arg is a U32. Okay, let's see if that's 69. No, that's 0. Okay, is it not 4? MIPS registers. Come on. Load faster. 4. Yeah, it should be 4. Fuck. I mean, maybe this is because I'm not setting these flags anymore. Let's set the flags to whatever it was. Context.context.bits32.flags is equal to, what was it? What was it setting? Is it this 1017? Okay, that's not doing it. Let's try 69 or 64. Oh shit, on a brick. Okay. Okay. All right, F. How big is F? Like, what is F? I guess F is static, so what do I want to do? I want, 42069. Let's make sure that's not a fluke. Maybe I am running in 64-bit mode or some shit. Shit, what would this be then? Do I need flags? Yeah, I do need flags. I do need flags. So 1 maybe signifies that it's that, and maybe it's not fur. Maybe that's just coincidence that it lined up there. What could that be then? For FP int FSR fur, that's context 32. So this would be yeah, these fillers will line it up. So that's actually in the same location. That fur is actually the same. It's the exact same location. So there we go. Now, okay, thread entry point. Oh, maybe we don't even need RA. Yeah, that's literally just RA. Okay. Set A0 argument. Okay. Okay. So now it makes sense. Fur is entry is U32. Flags, flags to, I don't think I need this top shit, to be honest. And in that case, this is, actually, I probably just need this. Yeah. If I do 1, I'll get execution, but it'll be 0. If I do 2, I probably won't get execution. Okay, I do get execution regardless. If I do 4, I'll have the 42069. Okay, so 7, this is, we'll just do this. Context control, U32 is 1, 2, 4. This is context floating point, and this is context integer, and I think by all of this stuff, okay. Context, floating point context, and integer context. Okay, and then this is control context, control context floating point, and context integer. Okay, so set the flags for the registers we want to control, and then this is probably just bit 64 flags as well. Yeah, that'll be in the same position. Okay, so bits 32 is no longer being used, which is good. So now bit 64 flags is control, floating point, and integer. 1, 2, and 4. 1, 2, and 4. We set the entry point. We set the A0 argument. We set the SP to be the end of the stack to the byte, literally out of bounds of the stack, so it has to sub to be in bounds. And everything else looks really good here. So I don't know how I actually use F. So F has a static lifetime. And fuck. Static means that the closure and its return value must have a lifetime for the whole program execution. Yep, that makes sense. The closure itself, builder spawn F. F may be a fat pointer. But the address of F should be constant, right? The address of F shouldn't change. Is that true? Okay, that's looks like an address. Let's print that as hex. What did that not work? Oh, I think that just didn't flush or something. Okay, so then what we can do is we can say that this is, yeah, but we don't know what that type is. The fuck do you do that? I mean, unless you're supposed to do the dot call once. Still need dynf in once. Here, like ref dynf in once. Is that a thing? So the problem is I need to be able to get args. That's not FFI safe. Yeah. How do I get args? Because FN once has args, and dude, I have no idea how this shit works actually. FN once takes a by value receiver. They can be callable, might not be callable multiple times. Because of this, if the only known thing about type is it implements FN1, it can only be called once. When you want to accept a parameter of function like type and only need to call it once. So what are args? I guess that's a generic. Yeah, so args is a generic. So FN once has a generic args. The easiest way is to box the fat pointer. Yeah, but how do I get the arguments? How do I get the args of this? Like, how do you invoke that? Or do you just do it with sugar? So call once has arguments, but oh, I see. So like this, I'm not gonna be able to do this, right? I mean, do you have to box it? And then you just call arg at that point, right? Does that make sense? Because you have to move the context into somewhere. So then this is gonna be box new f leak as u32 as u64. Box leak box new f as mute f. Okay. Hard. What? Arg's not hard? Huh? Hello? What? So, I mean, that's not FFI safe either, right? I mean, what if we just say this is a fucking Rust function? I mean, it could be a much more complex thing. Do I as pointer the box? Box it twice. I can do this into raw. I think I want into raw is what I want. I don't actually want to leak the box. Leaking the box is wrong. This is I'm doing it wrong. We want to do box new box into raw of that, which is then the raw pointer, and then I want to reconstruct it from a raw pointer. So now I have a mute t. Well, I have no idea what the fuck t is. Fuck. Yeah, like how the what? Mute t. How do I know what fucking type this is? So that box is an F? You don't? Yeah, I know, but how do I know what to box from raw? How do I know what to box from raw? Because box from raw requires typing. I guess that's what is that? A dyn. Can you do generics on externfns? Like, can I do this where I know that this is a mutable pointer to an F? You can't. Well, it's not a box dyn t. All right. So then how do I know what T is? I just never know what T is. Hey, Bitcoin, how you doing? Thank you so much for that 19 months. What the fuck, man? I, like, don't see how this is possible. Like, I don't understand how there's any way to do this. Like, how do I ever get F back? Because I don't know what F is. Am I dumb? Can I do this? Because, okay, yeah, okay, you can't do that. In your spawn, decompose the fat pointer into a mute v table using to raw parts. In entry, combine the pointer from raw parts mute. But I can't. Double box doesn't work, I don't think. Because I still have to know the T of the internal type. At the end of the day, I have to know what this F is. And if I don't know what that F is, see, here's the thing. If I have a, how do I declare that function, right? If I have a fn foo, and I have an arg, right? If it's a box of a box, I still don't know what this is, right? At the end of the day, to create that type again, I have to know what F is. I have to. I mean, is this any type territory? Or is it this? Can you do some weird generic-y shit like this, where this is a box F? Entry. Actually, let's try this. Entry F T. How the fuck do I do this? Oh, I guess this is turbofish on that? Yeah, so that works. And then yeah, so then can I just glory to the turbofish? Yeah, everyone glory to the turbofish. And then if I do this, does this just work? Arg, let's just say arg is F. Fuck it. Yeah, that works. And it's not complaining about anything related to generics. I think you can have generics on externs. Okay, now obviously I don't want it to exit. Well, we'll keep the exit for now. Func. So this is the external thread entry point. Okay, that wasn't nearly as hard as it seemed. Func. And result must be used, that's fine. Okay, unreachable in 27, that's okay. B-tree map unused, that's fine. Let's just clean up some of these things, get this to shut up a bit. Okay, so there we go. So that looks fine. Send it static, fn1's t, extern fn. And then, yeah, it's just, we're basically creating an instance of this function that has this typing, right? And then we pass in, oh, wait, what the fuck? I guess we don't need an argument anymore. Wait, am I wait, how the fuck did that work? Yeah, I don't think you need to pass in an argument anymore, because that is not, why do I think that's the case? I don't know, but I don't think you actually pass an argument. How do you not need arguments? What does it call? I don't know. I don't know, okay? I don't know. But like, I think this is, like, let astif is 5, and then can I print 5 in here? Because if I can... Ooh, okay, okay. So then what the f... let me try and do another one. Hey, okay. Yeah, that's not great. Okay, let's just close some of these. That might be working. Your V table for the callback is pointing to nowhere. Well, we can put this back in here and just see if that does anything. I think it's stuck. Mute F should work. So just, I guess just the F itself, the address of F itself. Zano Blano, fuck off. What do you mean that's not equal to 5? F. Obviously that's not gonna work. So this is, let's try adder of mutes F. Okay, so then let's try mute. Let's just say this is mute. Who cares? Fuck it. And then this obviously is a problem. We'll just say, whoa, Vim, chillax. Chillax, Vim. Extern. I think unsafe comes first. Oh, no, it does. Extern does default to CAV. Yes, yeah. Let's just be really naughty right now. Let's be really fucking naughty, okay? We're gonna be really naughty. Cannot move out of that, which is behind a mutable reference. Oh shit. Yeah, I think. I think you have to own F. Yeah, I kind of agree. Which then means this could be a box. There it is. It takes... I mean... Yeah, that's not a fat pointer anymore. That's not a fat pointer anymore. Right? So we box up F, thereby moving everything into the heap. And then we make that raw. And then we as U64 it. Technically... Yeah, and then we actually recreate the box here very unsafely. Here we could say that this is, fuck. Syscall. I think it's more correct to do... I think you have to box it. I think you have to. I don't see how you otherwise couldn't... Because where... Let's imagine you don't have box, thus you don't have alloc. Where are you possibly going to move these things to? Like, there's no place. There's no place to put a closure. It has to go onto the heap by nature. Because where are you going to put a captured variable? You can't use this stack because that stack is temporary. You can't use a global because you would run out of space if you have a loop, right? You have to box it. In which case, this is then a mute F, or more specifically, this is a mute F. And then we create the func. which is going to be box from raw of func. And now we can call func. And now this is correctly doing that, right? This is now correct. This is rebox the FFI'd type, right? Call the closure, right? So this takes a mutable F. This is specifically going to box that up. When we into raw that, that will turn that into the T that box contains. So if we verify this, we shouldn't be able to cast that to a U8 right away or whatever. The typing of this, let cbox closure box. I'm going to strongly type this as a box F, which is equal to box into box new F, right? Or more specifically, I'm going to say that this is a mutable reference to F. Box into raw, because now this is very strongly typed. This means that we're not automatically casting something by using as. We know for sure this is truly, after the into raw, it is actually a mute F pointer, right? And then at that point, we can invoke and do whatever the fuck we want, right? So now, if we go down here, we should be able to call this again. So this should, I guess that actually succeeds because, so I don't actually know. Oh, because we have exit. Yeah, there it is. Okay, and then obviously, +5. Holy shit, we've got real fucking threads! We've got real fucking threads! Fuck yeah. And then we'll strongly type this, even though we don't have to. We're just gonna strongly type it. So that way we fully round trip that, and then we call the closure. And that's it. And then that's an extern FN, so all of the typing works out. We could box from raw and entry. That's what we do, right? Oh, yeah. Yeah, and everything here is very, very strongly typed. There's nothing here that we're really doing that is... We're not really casting anything in here, which is nice. So obviously these will spin forever. So now what we need to do is we need to implement desired access. So we need to have the ability to wait, and I think NT wait one NT wait for single object. Okay, and this one's really easy actually. And this is also documented. So let's go find wait for single object is C4. C4. Okay. NT wait for single object. Sleep? No, we're not doing sleep. We're not doing fucking sleep. Okay. Pub FN wait for let's just call it wait for now. Handle. And then this is actually going to return that handle now. Handle. Okay, and then this needs to be a handle. Now, obviously, we're going to make this into a Rust type in 2 seconds, but we're first going to do some experimentation here. Handle. So we'll do syscall 3, unsafe syscall 3. What status is equal to NT status? This as U32 syscall 3. The handle is the handle. Okay, then we have an alertable. Specifies whether the wait is alertable. I don't know what that means, so we're gonna say no. And then a timeout, which is optional, and it's a pointer, so that's 0. And then we'll say syscall wait for single object, and I think it's just that fucking easy. Bink. 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 Okay. So what we should be able to do now is unwrap, and then let thing is equal to, and then we can do syscall wait thing. Thing 2. Let thing 2 is equal to this. Unwrap. Okay. So I think this is probably not working. I would expect I could get the printouts though. Is it crashing? Wait. Optional pointer to a timeout value that specifies the absolute or relative time which the wait is to be completed. A negative value is relative to current time. Positive is absolute. Okay. The alertable specifies whether or not the thread can be alerted and its wait state consequently aborted. If the value is false, then the thread cannot be alerted. Okay, let's do that. That's really interesting. Oh, these are failing. Those are failing. 100% they're failing. I don't have perms on the handle. That's what it is. I don't have perms on the handle. So this is results, right? And then this is the same thing. Convert error to rust error. Boom. If it's successful, then okay. It's 100% what it is. These are just literally failing, and then that's causing it to exit. Yeah, unwrap on error, NT status this, and it's probably eperm or some shit. And now we have to just go up to here, and then the desired access mask for the thread. We can use the desired access that they actually used up in here. Which was what? This is the desired access, right? This is the desired access. I don't know what the fuck it is, but it's probably good. And there it is. And now we are actually waiting for those things to complete. Okay, so we'll go figure out that access mask. Someone remind me to do that when we have to. And then wait is going to go away. That's no longer pub. What else is pub in here? Result, NT status, handle, IO status block, mmap is okay. This is unsafe pub, so that's okay. Write is fine. Spawn is fine. Exit is fine. This one's no longer pub. So this is wait for handle block on a handle forever. Right? So that's going to block on a handle forever. Syscall wait. Wait is a private function. That's fine. So now this is going to give a join handle. And that's a join handle, I think, of a T, actually, is what I'm going to want, isn't it? Yeah, that's a join handle T. Let's fucking go. Struct join handle T. And then join handle, the restrictions on that are none, apparently. Okay, so we have a join handle, and this is the handle. So this is the thread to wait on. Okay. So I don't necessarily know yet what join handle is. So let's just say a join handle here, and then impl join handle. Fn join. For now, it's just gonna be this. This is gonna call. Fuck it. This doesn't need to be a function. Okay. Yeah, I could see us using wait a lot, actually. And then here we'll do self dot wait self dot handle mute. Just self's fine, actually. And then this is a result. Okay. Thing dot join. Do you really want to get values from a thread? Yeah, I kind of do. Kind of fucking do. pubfn. So this is the join handle. Okay, then at the end here, instead of a handle, this is going to be a join handle. And that's going to be sufficient, actually. Okay, 269. Handle. Yep. Yeah, that's still a U size. So, bam. Now, that looks pretty good. Okay, how the fuck would I get a result out of that? Does this return a T? No. Do I make a box that can hold a T? I make a box that holds a T, and I have func return it. This returns box T, or this takes in a box, and I keep that box around. And then only once it's exited do I grab that, right? Right? Mute T. Rebox the FFI'd return value, right? Something like this. And then I can say ret is equal to this, right? Is this mute? Right. Now it does uninit. Well, obviously this is wrong. Yeah, I dropped the box. I know I dropped the box, and that's a problem. And it's also uninit. So I want to do box new uninit, right? So this is actually going to be this is okay. So we're gonna create storage for the return, right? So create return storage. Right? So the return storage that we're gonna create is going to be a box new uninit. And this is going to be our box, return box, is a box that contains a T, which is the return type. So now we've done that. So now this is going to be our box as U64. Now, obviously, that's a problem. So we're going to do box, box into raw. Yeah, we can just do that. Box into raw from box new. That is going to be mute T, right? Actually, this is maybe uninit T. New uninit. Okay, that's... Oh, we got some experimental shit. Fuck yeah. Add it to the list. Add it to the fucking list. Use... Is that core pointer? Use core mem, maybe uninit. This is gonna be fucking awesome, dude. 207. How do you remember all of these variables and functions? I don't know, dude. Don't fucking ask me. Okay. Rebox the FFI'd. Actually, I don't care. This is a maybe uninit T. And I can leave it like that. And then this is going to be right? Ret.right. This. Is that okay? Is that okay? Is that correct? Can I do this deref? Because that's giving me a maybe uninit, and is a maybe uninit a pointer in itself? Right. Uninit is owning. Okay, so then... Okay, so we'll just do unsafe, standard pointer right. Well, I'm dereffing the box there. Oh, you getting hungry, dude? Okay, I could probably leave in like 20 minutes. Fuck. X.right. So the thing is, this is a box. I'm actually dereffing the box. I think this is okay, actually, because this mutable pointer is for the box. So I'm dereffing the box. Because otherwise I would do box from raw. Like, I could do box from raw and leak, and then it would be like really fucking explicit what's going on. Right? From raw ret. This is a box, maybe uninit T, right? That's the ret, and then I can just do this. Ret.right is that. I think that's unsafe. No, that's safe. Right, so mutable ret. Right. So this is unbox or rebox the, yeah, ret right func. Yeah, that's what I had. I don't know if I feel better about reboxing it. Just because it's a little bit more explicit what all the typing is on everything. You don't need to rebox it. Yeah, that's what I thought, right? Right, that's just the same thing. I'm yeah. And then I don't have to worry about freeing it because it's no longer freeing it because that's a raw pointer. And that's been into rod. And then all I have to do is that this RBox has to be saved in the, here. There has to be an RBox. That's gonna free. If you rebox it, you need the leak. Yeah. And this isn't going to free. Okay. So then I need to say, let RBox is equal to this. And then at the very end, we'll just say RBox. All right, so RBox is a mute maybe on an T. Then this is the return value. So handle to a thread and a pointer to the return value. Okay, 169. T. Yeah, T. Yep. Impl T. And then we have a join handle T, and that's the same T. And now we're getting really good at this. This should return a T. And then I guess we want to unbox that here. So we do box. So, wait for thread to exit. Then, we got a semi, where? 244. Our box here, yeah. Okay, 172, yep. So this then, wait for the thread to exit, and this still isn't right. And, so we'll rebox it now. And this will be, let, ret is equal to box from raw of self.1, right? Get the return box, and then we have to do a so okay, I need to just wrap this up, and then I think about the concern I have in my head. Okay, so this is a box, and then we can do a box dot assuming it. All right, so now we have a box T, and then we can just deref that, I guess. Is there an unwrap on box? I guess I just deref it, right? And this is okay. Box from raw, assuming it, and then I should be able to deref that safely. Yeah. Okay. Okay, we're starting to have a couple of these. I think the system is struggling right now. Yeah, I think it's just not very happy with the number of processes we have running right now, especially since they're all, I think, spinning basically. Okay. All right. I feel like the join handle should contain the box so the return value is freed, even if we don't call join. Yeah, that's fine. As long as it's a box, maybe on init, you're right. In which case, this will be deref of self.1.assume init. Yeah, that makes sense. Hey, Itson, how are you doing today? Okay, 283. So, well, so what I do just as pointer of it then? Is there a way to do as pointer? There's into raw. Okay, so we can do a box new uninit, which is a maybe uninit t, right? So we're making room for that. This is a box maybe uninit t. And then here, I guess I can do just ref rbox as const. I guess that's a ref deref rbox as const maybe uninit t. Should this consume self? Yeah, it should. But also, this is not, this is not correct. I don't think I actually want to store the box here. Yeah, I don't. I was right. I want this. This return variable, this box, cannot go away. If someone drops join handle, we can't remove the storage for the thread's return value. Yeah. How the fuck does join handle even work for that? That's really interesting. Because if you drop this, then it doesn't get freed anywhere. So who should free it? Should this be a once? This should be atomically protected such that it's not read until it's initialized, and it shouldn't be dropped until it's read. And when join handle drops, I should decrement the ref count. Should it be an arc? Yeah, should it just be an arc mutex, basically? Where the join handle, basically when you drop the join handle, that would decrease the ref count, which then if the thread also exited, it would decrease the ref count and they would both agree to free it, right? So it's definitely an arc. We don't have a mutex, but I'm pretty sure just an arc is actually correct here, right? I think this is supposed to be an arc, maybe an it t. Because that's going to be a heap allocated variable that's kept around until both of them no longer need it. Arc will add a sync bound on my t. Is that not the case already? I already have I have a send bound. I don't think Arc does it? I don't think... Yeah, Arc doesn't have a sync bound. Yeah, Arc doesn't have a sync bound. Arc, maybe uninit T. And we'll just panic for now. Okay. So now we can do an arc. Fuck yeah. Arc new uninit. And this gives an arc maybe uninit T. Right? So you have an arc maybe uninit T. Then that rbox, we're going to do rbox.clone as pointer. Provides a raw pointer to the data. I don't necessarily want to do that because I want to move this into there. Is there an into raw? Yeah, there is. Okay. Okay, here we go. Arc into raw. Bam. So now we have two. We have the original one, and then we cloned that, and then we into rawed that, and that gets moved by ownership into there. Right? Use alloc sync arc. Okay. All right. Perfect. Arc is only send if T is sync and send, but I think that's okay. Because you shouldn't be, I don't know. Sending it to another thread. Yeah, I know. I mean, wouldn't this compile time fail right now? Okay, let's just do this. Arc dot unsafe self.1 dot assume init arc try dot try unwrap dot unwrap. Okay. Can't be called due to trait bounds. Yeah, that's map error. This is wrong. We're just hacking right now. That. Okay, so let's see. RC new 5. Alec, RC new 5. Yeah. Right? RC can't be sent between threads safely. Because if the thing is, if T doesn't implement send, then I wouldn't be able to make, I wouldn't be able to make this, right? I couldn't make an arc maybe uninit, because a new uninit is safe. This is a safe function. So Rust wouldn't allow me to make a safe function. Or Rust wouldn't allow me to make an arc maybe uninit T, right? It wouldn't allow me to safely make this type if this is not a valid arc, right? Right? You see what I'm saying? Like, this is like, the type system allows for things like this. You can make an arc without a T send. It has no and then you can into raw that. Okay. The bounds are only applied when you send, when you require send on the arc. And I'm erasing that. I see what you're saying. How do you lay out your Rust projects? I keep wanting to do some dumb projects. I kind of lay them out relatively normally, although I've gotten a lot better at kind of setting these up. 1 second. I'll get back to that in a minute. I need to wrap this up. I need to. Okay, so this is maybe on an init T. Rebox the return type, and this is let arc maybe uninit T is equal to unsafe arc from raw ret. Okay, so we're making that. Okay, that can't be more dismutable. Yeah. Okay, perfect. That makes sense because now what we need to do is we need to make a syncable type. And this is kind of what I was expecting and where we would start to have some of the failures. 219, that's not required. Okay. So obviously making those again is unsafe. And this cannot happen because, let's see, this arc should be fine. So what I need to do is now I need to make, I basically need to make a mutex, right? I need to make a mutex here because I need to have the ability to convert this into a safe between threads thing, right? And that's why I'm not super worried about the sync, because I'm going to end up taking this whole thing and I have to wrap this in a like a mutex, right? An arc mutex maybe on init, right? And at that point, I now have send and sync on that. Right? Because right now I can't, like, right now this doesn't make sense anyways, because I don't have mutable access. Like, it's, I think it is currently, I guess it isn't fine that I'm sending this. Is it? Is this currently okay? So for arc to be send, T has to be sync. Yeah, and sync allows for references. So, So what I need to do is a mutex would basically add sync to something, right? Yeah, as long as T is send, then a mutex makes it sync, right? So right now this is wrong because I need a mutex type, and we knew that kind of ahead of time. In standard thread, they don't use a mutex. What do they do? Memory is shared through the arc within, and there's no need for a mutex here because the synchronization happens with join. Yeah, so that's kind of what I was thinking, right? Is we can piggyback off of the fact that that join is that mutex in this case, because we kind of don't want to unnecessarily complicate this. So what I can do is I can arc, let's see, so, I'm guessing they just unsafely use this, right? Yeah, this totally makes sense to me, right? This is exactly what I would kind of expect. So what we can do, since the sync bound is this, we should simply, I don't even think we need an unsafe cell here. We can just be, I mean, I guess, do we need an unsafe cell? Yeah, let's just do an unsafe cell. Unsafe cell. And, so should this be an unsafe cell, maybe uninit T? So an arc unsafe cell. Is core cell unsafe cell. Right. 220. Can't find this on unsafe cell, and then we'll do a get mute. That's raw get. Get to mutable pointer. No, that's new. Okay, dot get. Oh, dot get. There we go. Yeah, dot get. Deref that, and then I can do that right. Obviously that's where the unsafety occurs. So I do dot get. That gives me a pointer, and then I deref that, and then that gives me a mutable reference, and now I have a mutable reference to that. Something like that. Something in that ballpark. Fuck it. Let's just put this in the unsafe. Boom. There. Okay. So that is going to call the closure and save the return. And then that's an unsafe cell, and then down here this needs to be unsafe cell. That. Okay. Unsafe. Arc new uninit. Ooh, arc new. Ooh. Unsafe cell. New. And then I need to say maybe uninit on the inside. It's getting a little bit fun here. This is a maybe uninit new. Okay. Okay. Basically, anywhere that we have an arc, unsafe cell. Arc unsafe cell. That's gonna be wrong now. Arc unsafe cell. Arc from raw. Arc unsafe cell. Into raw. Okay, supplied 0 arguments. Maybe uninit, unit. Okay, now 179. Obviously, assume init doesn't exist. We need to do this on so this is gonna be So now what we have to do is we have self.1, which is the arc, and then we want to, from that arc, we want to do a get, which is going to give us a mutable reference, and then a mutable reference to that. Or actually, we just want to, it's just an into inner. Arc. I need to assume in it? No. Unsafe cell. And then that, assume in it. Into inner on an unsafe cell. Unwraps the value? Is that safe? Okay. And then that is unsafe. Okay. Move occurs because value has type unsafe cell, blah. Doesn't have the copy trait. Into inner. Yeah, I don't want to do that because that's on arc. I want to do this on, I guess. Actually, I can just do this. Get mute, unwrap, assume in it. Oh, fuck. That. Wait. That gets me a mute T, a ref mute T, mute ref T, and what? What? That's get mute on the arc. Or is that going all the way to the ref cell? Arc get mute. Mutable reference to this arc. Not found on mute unsafe cell. And that. Do I have this? Into inner. Oh! God, this is so fucking weird. Into inner. And I mean, is that okay? Can I just go from that to the, I think I'm just fine. Because I'm just at the maybe on init, and I think I can just assume init. That borrow is mutable. Yeah, okay. Here's what I need to do. First, I need to get rid of the arc. And to get rid of the arc, I need to, on the arc, I kind of want to try unwrap that, right? So I have self.1, and then we can arc, try unwrap, and this should give me dot map. Right, so this should now give me the unsafe cell. That's the unsafe cell. So now I have an unsafe cell. And now I want to get rid of the unsafe cell. And to do that, I need to, I think I can just do into inner on that. Right? Okay. And then, now that I have that, that's the inner unsafe cell, and then I should be able to just assume init. So this should be okay unsafe inner dot assume init, right? Into inner, not found on this. Map error. Yeah. There you go. Okay. And theoretically, this will allow me to do this. And I should be able to now return a, like, RC new 5. And this should be a Alec, or... yeah, Alec RC, right? Oh, that doesn't have send. I guess you can't send that. What's a good one? Ref cell? Yeah, there's a good example. So then this is 1, 2, 3, 4. So a ref cell is definitely not sync, right? A ref cell is not sync, but it is send. But we can't get the value unless join completes. And if join completes, then we actually have the results. So what I should be able to do is do this. And this should now print result is this. Maybe. I think I might have erase on the prints here. Maybe? No? What's going on? Why don't I get a final astiff? Am I still exiting? No? Why? Those are getting stuck on the joins. The VM is about to be very unresponsive soon. Okay, so wait. Is wait not completing? Because these threads aren't exiting? Oh, yeah. These threads don't exit. We need to explicitly say that this function doesn't return. And then we're in pretty good business. Okay, that makes sense. That makes sense. So I need an exit, like NT exit thread. That probably exists. NT exit, ZW exit process. Terminate thread. ZW terminate thread. There we go. BB. The threads aren't exiting. That's the problem. Okay. Wow. NC terminate thread. And I don't know how terminate thread works, to be honest. But it's BB. Okay, so we'll just inside of here. What are they returning to? Nothing. XBB, and then we're gonna do unsafe syscall 1. I don't actually know what ZW terminate thread is. Looks like it's the same as exit. So we're just gonna go to exit. Exit thread. Okay, terminate thread. Okay, exit thread 0. Okay, and then it's hard to say if this system is even doing anything anymore. So we might have to kill it just because we have so many of these things open. And we look like we're good. Okay, now the question is, will this work? No. That's still open. Terminate thread. Terminate thread. BB. BB. B. BB. Here's terminate process. BA and BB. Fuck. Code that. Do I have to have the thread handle? I might need to have the thread handle to actually exit this thread. Fuck. Get current thread. Get current thread. Sudo handle. Is it not? Is current thread not actually -1? Is it -2? Does anyone know what get current thread is? Just doesn't end. It doesn't let up. Printf %d get current thread. Because we know that get current process should be -1, and I think get current thread might be something else actually, and that might be the issue here. Please, please be something other than -1. Thank fuck it's -2. Oh yeah. Okay. There it is. 178. That's failing because that's not dropped. Oh, yeah. Try unwrap. So that if that unwrap is failing, this is at 58. Oh, this unwrap. Yeah, try unwrap should succeed for an arc if there's only one ref. If there's exactly one strong reference, and there should be only one strong reference, unless for some reason this isn't getting dropped. Maybe it's not due to the exit thread. Drop ret. Interesting. Does calling in a function that doesn't have an exit not drop? Drop the closure and the return value? It doesn't drop? Really? Okay, so I'm just gonna do this then. Okay, I think I think that's the best way to express it, right? Okay, exit thread 0. All right, so now ASDF, and now we should be able to actually do this. Let's just debug this. And yeah, there we go. We have a ref cell value 1234. Woo! Okay, so it is technically, I think, still, I don't know what happens if that thread, I guess that thread, I don't know what happens if that thread, let's try this. Unsafe. Does wait expire here? So what we're gonna do is unsafe core pointer right volatile 1 2 3 4 5 6 7 8 0 as mute u8, right? We want to basically cause a crash, and we want to make sure that that doesn't continue, and it looks like it doesn't. It looks like when that crashes, wait just hangs, and that's what we want. We need to make sure that wait hangs, because if wait doesn't hang, then if wait doesn't hang, come on, Control C. Okay. Basically, we need to make sure that wait never finishes unless so basically at this point, this try unwrap actually is asserting that the value has been updated. Because if the value has not been updated, the only way that this try unwrap succeeds is that if there's only one arc reference. And the only way that there's only one arc reference is that if we made it to the end of this scope and it caused the arc to drop. If we crashed or anything happened between those points, that arc wouldn't have actually dropped, since we're panic abort. And thus, first of all, this wait would never succeed. And second of all, if somehow this wait did succeed, this would unwrap and it would fail because there's not exclusive access to the arc. That's my logic there. I don't even think we need the unsafe cell because of that. Like, literally because of that. Like, I guess we need the unsafe cell such that in here we can write to it. And that's it. That's the only thing, is that we can be able to write inside of an arc. And that's the only reason why we need that. So then if we run this, we'll run these programs. And I think this is actually correct. Because the arc, we are relying on the arc completing for this to, we're relying on there only being one arc. And if there's only one arc, then we know that it has been initialized. It is impossible for that arc to be dropped without being initialized, if that makes sense. So that is kind of our safety there. And then these obviously all require send. Everything here has to be send. We're inheriting sync because we know that we only have one user of it. We're not using it between multiple threads. We're only using it in one thread at a time, because this thread can't use it until there's only one access. And that means this thread, which is the only other one that has access, is also fine. What if you drop handle immediately after spawn? Oh, that's totally fine. Like, I would just drop the handle and I wouldn't be able to get the result of that thing. But like, I can just ignore those and I just won't see the output. Like, right, if I just drop both of those, if I drop thing and I drop thing 2, this program is just going to exit, right? So if I put a loop in here that allows those threads to exit or run, they should still print, right? Those threads are still running. Basically, by dropping this, we lose the ability to be able to get the return value and to determine whether or not the threads have completed, but we don't actually lose access. The threads don't stop. That doesn't kill the threads. Won't it deallocate memory for arc before reconstructing it from raw? So we move ownership entirely of the function into the thread, and then we move ownership of one side of the arc. Now, this will drop one side of the arc, and then this will drop the other side of the arc. So it'll initialize the arc, and then it will drop it, and then it's gone. So I think this also has no leaks, right? And we could kind of verify that by just putting threads in a loop, and we could just say like drop, or we could do thing.join.unwrap, right? In a loop. And I'm gonna kill this process because we did zombie one of these, and then I think we're good. Right? Okay. Yeah. So we're creating threads. We're creating a shit ton of threads, and we shouldn't be seeing like anything really leaking here. We should be able to hopefully have a view for this. View. Come on. Alt V. Oh, okay. I can't send Alt V apparently, but I can do that. Haha. Let's go to handle count and thread count. There we go. Okay, so we are having, we're leaking handles, so we need to close that handle, and that's the last thing we have to do, and then we're done. That's it. We have to NT close handle, which literally takes 1 arg, and we were kind of expecting this. So this is basically any place that we create a handle, process handle, that's an input, so that one's fine. That was an input, but any place that we have an output handle, which is really just here, we have to actually close that handle as well when we're done with it. That should be the only handle that's leaking. It might also be putting handles in this client ID. This might have handles as well that we have to drop. I'm not 100% sure, to be honest. NT close handle. Or NT close, I guess is what it's called. NT close there. F. Okay, NT close. It takes a single thing. It's a handle. NT close F that. Okay, now I didn't want to run that. Whoops. That and that. Okay, and then yeah, there might be some other handles in there. Let's just quickly we'll do this. We'll just say fn close close a handle. This is just called 1. Then we have the handle.0. And then this is close. Okay. And we technically want to return the status, but I just want to make sure that this works before we do anything. So in the drop handler, so right in the drop handler here, we want to do a close on handle. So we wait for that, and then we can close that handle. Okay, so if we're still leaking, and it doesn't look like we are. Okay, so that was the only handle. So there's client, right? And the memory usage is not going up, the thread usage is not going up, the handle usage is not going up, but it is indeed running threads, it is indeed spawning them over and over and over again, right? So they're spawning threads, we're creating them, we're waiting for them to complete, and then once they complete, we close the handle. We close the handle even if we're just dropping. I guess that's on join. We don't want that on join. We want it. Fuck. Then I think we're pretty much done. I didn't mean to run clients again. Okay, close those. Now we actually want the drop on this. Impl t drop for join handle t. And f and drop mute self. And then here we want to do close self.0. This is close the handle, right? Because this way, if we don't do join, we'll still end up dropping that, which is what we want. Move out of here occurs. Doesn't implement copy. Is that because we implemented drop now? What? Is it this? Do we have to do this? Nah, we shouldn't have to. We shouldn't have to do that Can I also do this? Can I self this? No. Just having drop fucks that up. Why? Cannot move out of join handle. Oh, because Could test again without the join. Yeah, well, obviously that's not gonna work. So, I mean, I can do close self.0 here, and then I can just leak self, I guess. Fuck. That's really fucking annoying. I need to revisit that. I need to move that out of self, but I don't have a good way of doing that, unfortunately. I mean, I can't. Want that impl drop on the handle instead? Well, I can, but I kind of was using handle for other things. But I can do that, right? But now I have to stop using handle in like a trillion places, right? So basically anywhere that I use handle no longer needs to be handle because we don't want to drop those handles. Like this right, for example. That's not a handle that we want to drop. I mean, that could be a ref handle, and then it's not a problem, I guess. But we create those handles in a couple places. But yeah, that is the way that we should do it. I'm just gonna put close here, and then I'm gonna say add drop for that as a to do, and then I'm happy with this because it kind of works and whatever. And we can close clients, and then I can close this, and then blah blah blah. This. Debug this. Okay. Okay, that looks great. So that created a thread, waited for it to complete, and printed out the result. So that looks pretty good. Git status, git commit am, git add source, git commit am added threading support, git status, git push, and then here we'll just do this. XXX to do fix leak of a handle. Okay, there we go. Now we know to do that. Git commit handle has leak. And we'll put this here. And then up here, and then this if dropped without join. There we go. There we go. And now it's Windows code. Git push. All right, there we go. That looks good. Thanks everyone for tuning in. I'm gonna go eat. See you some other time. Bye-bye.